Hi all, today I'll be discussing the Starters 253 Code Chef contest questions which took place this week. Let us go to the question, grid jump. Let us read the question. You're standing at a point 0, 0 on a 2D coordinate grid. You would like to reach point A, comma B. You have the following movements available with you. Move 2 steps. If this is the point, we can move 1 or 2 steps towards the right for a cost of P coins. Either move 1 or 2 steps up for a cost of Q coins. Move 1 step up, move one step up and 1 step right for a cost of R coins. Finally, we need to return the minimum number of coins you need to spend to reach the point AB. Okay, let us understand the question. Okay, we have to reach 2, 1. Let us take the first point, which is 2, 1. So, in order to reach it, we have the following moves. We can let us look at the input 1 second. Yeah. Okay. So this input gives us the points A, B, and then the cost P, Q and R. Okay. So we are given 2, 1 which is AB, and we are given costs 6, 3 and 4. So let us understand it. So we are currently at this position and we have to reach this position. So first what we can do? First we can go from here to here, which is 2 steps right for a cost of P. Then we can go 1 step up for a cost of R, which will give us a total of 6 and 3, which is 9, and that will be the minimum number of moves which we can do. Next, we have to reach 2, 2. So let us check with, first we are going to check what moves make it easy. If we check, if we have to go to any number which is greater than it on the right side, always there is an option. If it is greater than A, we can always go to a diagonal, which will help us reach the point in a minimum cost, as the diagonals takes only 1 move up and the cost. So if we have to move here, we can directly go here and here, or we can go here and go up. These are the 2. We are going to check the 2 possibilities, and based on which we can see that if we go through the right move and up move, the total cost is 9. If we go 1 diagonal up, 1 right move up and 1 right up move, that is going to give us the total cost of 13. And here if we see, if we directly go 2 diagonals up, this will give us the least cost, which is 8. Since we have R as 4, I guess, yeah, R is 4, so this will give us 4 2s as 8. So this is the best possible move, which is in which the minimum ways we can reach the point AB. Here we need to reach 3, 4 from 0. There are 3 choices. You take you take 1 or 2 moves to the right for P, then go up 1 or 2 moves for the Q, and then go to the diagonal. So you have to reach 3, 4. Yeah. So we have to reach this point, which is 3, 4 over here. So we can directly move up 1, 2, 3 diagonals and go up, or we can go 1, 2, 3, move 2 up and then reach here. Go 2 here, go 1 here, go 2 and then 2 again. These are the possibilities. Let us check the costs. In this case, in the first case where we do 2 right moves and 2 up moves, total cost is 8. We took 1 diagonal and 1 right move and 2 up moves, which is 9. We took 2 diagonals, 1 right move and 1 up move, which gives us a total cost of 8, and 3 diagonals and 1 up move, which gives us a total cost of 9. It is not always mandatory that using the diagonals will give us the minimum cost at all times, since in few cases we have to go back which is not possible, and few cases we need to go extremely front if we are not near if the goal point AB is not near the diagonal. So we always have to find the possible moves, find all the total costs, and return the minimum cost of it. Let us look at the code. Let us understand the formula. So first thing is, we are going to find how many k can we go, the number of diagonals k. Let us assume the number of diagonals as k. So if we observe each test case, we see that in every move the number of diagonals we can go at max will be the minimum value of a and b. So first we find the minimum of a and b, which gives us the number of diagonals. Next, to find the remaining right moves, we do a minus k, which is our point a, minus k, which will give us the remaining right moves. Next, how many remaining up moves are there, we'll find that. Then we find how many right moves are there, how many remaining rights are there, how many remaining ups are there. Then we find the number of right moves we are making, number of up moves we are making, and finally in the last we find the cost. For each possible way we are finding the cost, and at the last we are going to return its minimum. So this is the formula I have used. Let me show you the code implementation. First we are going to, as always, we are going to read the test cases. Next, take the input points a comma b and the costs for each kind of move given to us. Next, we are going to declare an answer variable. We are going to run a k loop where we are finding k from 0 to minimum of a comma b, which will give us the maximum number of diagonals we can move. Then we are finding the remaining right moves, remaining up moves. Then we are finding how many right moves, and then we find how many up moves, and finally we find the cost with which we multiply the number of diagonals we have taken as k, the number of right moves we have multiplied with p, and the number of up moves which we have multiplied with q, which are their respective costs given to us in the question. And finally we store this value for every iteration, and at the end we are going to return the minimum value. Find the minimum cost required and print the answer. So we are going to find the minimum cost required by using the min operator, where we are applying it to the cost we are doing and the answer variable which we have stored. Finally we print the answer. I hope you have understood it. Thank you.